The next speaker is going to be Héctor Beade. Héctor Beade is also a Spanish Ingeniero de Caminos, civil engineer, but in this case from La Coruña. And he's specialized, of course, in structural engineering. He graduated in year 2000, so he has now 15 years experience. Much of it in a very well-known Spanish engineering design firm, which is Arenas Asociados, and he's currently working in Knight Architects. His experiences ranges from small footbridges to very long high-speed rail viaducts. So you have the word, Hector.
Thank you, Hans.
I think.
So, good morning. The title of my presentation is Bridge Design. Can a methodological approach be defined to guarantee a good solution? It is an ambitious topic. The aim of the presentation is to define a series of steps where the designer should stop in their way to a good solution, but the final objective is to make something useful as a tool for reflection on bridge design as a process, and to reflect on why there are so many bridges out there which are out of the range of what could be considered good designs. We have seen some of them already in the Sebastian presentation. So we'll start with some examples of bridges that moved me to write about the topic. So I will start with what I call narcissistic bridges, which are bridges that feel strong, high, and feel good looking, and use the spans they want independently of the obstacle they need to save, and they can be where they want in large cities of the United States, or the same bridge can be in a small city, the north of Italy, independently if what is spanning is clear or not. It can be in the city, the town, the countryside, the same solution. What is important is the bridge, not the context. It's not important if there is an obstacle to be saved sometimes or not. The same landmark can be used in the countryside or can be used in the countryside or in a large city or in different urban contexts. The previous examples were probably arguable solutions are bridges, but could be considered as nice solutions. Some of them as macro sculptures. When others try to do the same, copying the same layout, the result is different. They don't have value even as macro sculptures. There are other type of narcissistic bridges, which seem to be the opposite, but they share in common that they are only worried about themselves, about solving the crossing problem easy and fast, and with low investment in design. They can be extension of historic bridges, or they can cross rivers with all their peers inside the waters of the river, or to be used to solve complex road junctions. So these bridges have in common that they have low or no investment in design, and they sometimes make the client feel like they are investing in the design with the overall cost, which most of the time is a wrong assumption. So investing in design tends to be a saving if you look to the overall picture. You will know a lot of examples all around the world of this type of bridges. This is the same, but with a footbridge. It's an example widely used in Spain because you don't need a designer, because you just need to use some drawings published in the 70s and to modify them, and you have a bridge. You have a bridge with a side span over ground which is longer than the main one, which is a bad design, clearly. You can find this type of footbridges everywhere. It's an example of Scotland, Peru, Thailand with a fancy dressing, but the same type of bridge, or a colorful example in the Philippines. All these bridges are not important for many people, even for the clients, for politicians. They think that they're conventional bridges that they just should think on the signature ones, which are the ones that are sold politically. But all of them need to be there for 100 years or more. So every bridge is important. Every bridge should be carefully designed. And this doesn't mean that it would be more expensive. This is an example of how a designer is considered useless sometimes. Is having some U-shaped precast concrete beams, you have a footbridge with the parapet included. So why do you need a designer for? And the pipe, it's outside the bridge, but who cares about these things? So nowadays, well, there are no limitations in terms of and structural analysis, construction, and geometrical modeling. So everything is possible. Bridges that were not an option years ago. So some examples are good, some others are improvable, but everything is possible. So this, well, this makes that sometimes things are built because it's possible. That's it. This is an example of a bridge. It could be in the narcissistic chapter. It's a footbridge with 4 different ways to cross, and all of them have steps. So functionality is not relevant. Any disabled person, no disabled person could cross the footbridge comfortably, but who cares? There are hundreds of examples of bridges that sometimes are structurally orthodox, but you think that they should have been better, or well, this is an example like of a bridge that crosses a river with a cable stay scheme, and all the substructural elements are inside the water of the river, which is surprising. And some of them are likely wrong from the structural point of view, or very wrong, as this one. This is another example. You can find them everywhere. This will be orthodox from the structural point of view. It's a bridge type that is difficult to make it work visually well, but will be right. This is a bit more strange, but maybe right. And this is absurd. So, well, this is just to contextualize that there are no limits, and everything is considered and even built. There are other examples that you don't know if they are absurd or not. It's difficult, or it's worthless trying to understand them. They are everywhere, close to my home. This is an image of the 2 well-known bridges in Seville, Alamillo and Barqueta Bridge. This view show them overlapped in elevation. It's a view I don't like especially, but well, it's widely used for marketing purposes. And someone thought that it was a good idea to combine them in a single bridge. So this is a bridge in Malaysia that has the 2 schemes that it's difficult to think that they will work well together. But yeah, more examples of bridges that were considered at some point as winning solutions in competitions. And sometimes they are built. This is the same scheme as the footbridge we have seen before, which is structurally absurd. An example of how a design can be good or bad depending on the context. This is a famous bridge, the first multi-span cable stayed bridge, which looks, well, reasonable in the immensity of the Maracaibo Lake in Venezuela. Looks weird, a bit wrong in Libya, in this V-shaped valley. This should have been a deck arc, and completely out of place in a urban context in Geneva. That's what comes to my mind. So to compensate part of the negativity caused until now, I'm going to show you some examples of bridges that I consider good designs. And the question is, does a good design need to be striking? So these are just some bridges I consider good designs. This has been shown before. So that was an introduction to the methodological approach. So what I'm going to describe is a series of steps that most of them are common to other design disciplines, as product design, or graphic design, industrial design. So this is, in fact, application to bridge design of something that has been stated before for all the design processes. Sebastian has used the principle of dithyrambs in his footbridge presentation, so this is an example of how every design process is related to others. The first step on the process will be the problem. So in this case, the problem in bridge design is simpler than in other disciplines. As in industrial design, the problem could be very variable. The problem is always the need to cross from one place to another. So the first question will be, do we need to cross? And if we need to cross, do we need a bridge? So this is the responsibility of the client, of the owner. There are a number of bridges that have been started to build, and after decades they are still unfinished. So it's probably because they weren't so needed. So this will be the first question. The second question will be the problem definition, which is again responsibility of the client and the owner. A designer can be involved or not, preferably yes, and it can be the final designer or not. So some of the points to be defined would be the use of the bridge, if a road bridge, the rail bridge, combined use as pedestrian cyclists. Where to cross, plan alignment is very important. The width of the bridge, depending on traffic, and if it's temporary, it's definitive, or if it has temporary uses that are different to the final ones. So this is some images showing decision making on where to cross in a footbridge. This is a brief of a competition in the United States. So it was part of the brief. The client worked with a designer to choose where to cross before all the teams were involved. A recent project deciding where and how to cross, deciding the width of a bridge. This is an example of what I consider an improvable definition of the problem. This is the site of the International Exposition of 2008 in Zaragoza. There are two really close bridges, the Third Millennium Bridge and the Bridge Pavilion. The Third Millennium Bridge is a road bridge with large walkways and cyclist lanes, and the Bridge Pavilion is a pedestrian bridge that has some exhibition content during the event. At this moment, the Bridge Pavilion is mostly closed and is open at certain times with security guards. And the Third Millennium Bridge is less used than it could. So I think this is an example of a bridge that should have been a single one, and probably different to them too. This is another example in Spain of two bridges that are really close. The red one was the first to be built. 6 years later, the second one was built, which is not parallel, but is close. So it was decided to use the same geometry as in the case of the first one, but it wears a camouflage hood. And this is because the relation is strange, it's difficult. These bridges should have been a single one or two close parallel bridges. Next step will be the splitting of the problem into smaller elements. So if you try at this stage when the client has defined the problem, if you try to look for a solution for the problem, well, the problem will be very complex, and you will probably tend to do something you have done before and just to adapt it because you will be overwhelmed by the complexity of the problem. So if you split the problem into smaller elements that you can easily understand and to look for solutions to these sub-problems, solutions that could be maybe close to the optimal because there are sub-problems, you will understand better what you have in hand. So some of the problem elements will be related to the context, historic, cultural, social, environment, landscape, wind, seismicity, geotechnics. If there are other bridges in the area, is important. Also the budget, of course. So this will help to set the boundaries of your problem. This is in fact the the second principle of the Cartesian method, so it's really valid nowadays for many fields of knowledge. It was written, the discourse of it was written in 1643, so it's probably valid nowadays. Some examples of different environments, in this case landscapes, where a design could be located, rural or industrial and urban, or urban but in the historic city center, or peri-urban, related with the environment but not the landscape, geotechnics, hydraulics, navigational requirements, other bridges in the area. After this splitting of the problem into small elements, you will normally have this kind of drawings would help you to limit the boundaries of your problem, just to focus on what you can do or what can you cannot do. So you will have a certain span, more or less clear. You will know what materials can be used or not, more or less, and what construction systems may be compatible. The next step will be the data compilation. So it's not worth trying to invent the wheel in every project. So it's useful to see what has been done before. The first approach will be what have you done before, so or your office, so previous own experience. Then what have others done is also useful and recommendable. And it's also useful sometimes to look for inputs in other disciplines. So this is an example of an own project, seeing what has been done before in similar crossings, the same in another own project. What construction systems may be compatible with your case. In terms of materials, if you're using novel materials, stainless steel is not so novel, but it's useful to see what others have done. And at the beginning, when these materials are introduced for the first time, it's useful to see what has been done in other disciplines. Same, this is ultra high performance concrete. See what's the state of the art in terms of lighting is also useful, because it's something that changed a lot, and it's important to take into account lighting from the early steps of design to have a holistic approach, and not to add floodlights to a finished design, which would be probably would lead you to an improvable solution. But what happens if you go too far with the data compilation and you not use the same idea, but use the same structural scheme, the same arrangement of elements, and the same detail? You're copying a bridge, and when you're copying a bridge, it's unlikely that you have a good design or a good solution to your problem. Next step will be the analysis of this data. So this moment to have preliminary analysis of alternatives, which is so some examples is not just choose an alternative. You can choose a series of them. Just the important thing is to limit your scope, and you can choose as well a range of materials and compatible construction systems. Some cost estimations to know what you're doing is within the range of the budget you have. So we reach the creativity stage, but having done quite a lot of work before, so it's creativity within the limits of your project. It's not fantasy. There are apparently two ways of being creative in a design process. Both of them are cognitive, so require experience and knowledge in the field you're working, and ideally in other fields as well. So the first one will be the deliberate and cognitive creativity. So this happens in the prefrontal cortex, and it allows you to pay focused attention on what you're doing, and you deliberately combine bits of information you have in novel ways. So example, paradigmatic example of this type of creator will be Thomas Edison, doing thousands of experiments and failing, but always going a little step ahead with these failures. The other type of creativity that is used in design process is also cognitive. It also requires work, knowledge, and experience, but it is spontaneous. So it happens also involve the prefrontal cortex, but the role of the basal ganglia, where dopamine is achieved, is apparently relevant. And this happens in outside conscious awareness. So this type of creativity that happens when you have worked intensely on your problem and then you go to sleep or to go to run or do something unrelated, and magically an idea that solves your problem comes up. And this is not magic, it's because your brain has been working for you without being conscious. Newton and gravity, seeing an apple fall is the typical example of spontaneous and cognitive creativity. So the creativity stage is the stage is really wide. The stage of doing a lot of sketching, trying things, doing models, and testing, failing, doing some structural analysis to see if things work or not, checking if things are compatible with your with potential construction methods. So it's the moment of doing a lot of kinds of modeling or combining different types of modeling, even physical modeling. So we have reached the verification stage. Verification bridges is mostly structured, but can be also related to hydraulics and marine dynamics and so on. This is an important stage. It's more important if the bridges have a long span or they are complex or slender. But I would say that it's not the most important stage. A bridge can be perfectly analyzed and can be a really bad design. So many people feel comfortable here and are willing to get to this stage as soon as possible. That happens quite frequently. Well, some samples. Having said that it's important but not the most important thing, it's very important to do it well and to not pass your limitations in the structural analysis to the project. So if you don't know how to do things, just look for advice or try to learn, but don't try to go to where you feel comfortable just because these are your limitations, because you will be passing your limitations to the solution, and the solution should be as good as possible. Next step will be materials and technology. Well, we have mostly decided the materials that will be used and the construction system as well. So this has been done before, but now is the point when you decide more specific things, as the type of hangers you're using, if you have a bridge with cables, or the post tensioning system, or the type of bearings or expansion joints, and all these things can have an influence on the design, or can show you that they are incompatible with what you have been thinking. So this may force you to come back some steps in the process. The process is drawn as linear, but is in fact far from being linear. It's just for didactic purposes. It's very iterative, and everything is quite mixed all together. So well, this will be the point to decide if the construction method you have in mind is really possible, how it does affect to your design, if you have a space on site to place the building equipment you need for this construction system, and so on. Next step will be experimentation. This is not always needed, but it's good not to avoid it if it's useful. One type of experimentation will be related to materials, for example. If you're using new materials or materials that have been used before, but you're using them in a novel way, or some unconventional details you will be repeatedly used in a design. Wind tunnel testing is a typical type of experimentation carried out in bridges, and in this stage will be just a verification of previous assumptions. So if you really want to use the results to have a cross-section with a good behavior in terms of wind response, it will be useful to have the input in previous stages, or to link it to the verification or creativity stage. Next step will be the geometrical model. So it's the moment where we mostly have a design, and it's good to modelize it to check that there are not incoherencies, inconsistencies, incompatibilities, to check that everything is feasible to be built. It is also useful to inform the client of the progress and also useful to produce the drawings, which is the last step. So the drawings will be the perfect definition of the bridge you have designed. It's important, the drawings, because you can have a great design, but if you don't define it properly, maybe this construct is not exactly what you have designed, or it's an excuse to change things. So a good design should have good drawings. Some example of drawings in some of my designs. And we have reached the solution. The solution with all this process should be a good one, or at least in the range of the good ones. The method by itself is useful, but it's not enough. You need also a skillful team. Team is an owner and a designer, and also an appropriate allocation of economic and time resources for the problem that is being solved. So that's a series of conclusions. So, well, the methodological approach intends to be a tool to reflect on why there are so many bridges that are improvable, let's say. Yeah, the service life of bridges is 100 years or more, so every bridge is important, and the work of the bridge designer is a work of a great responsibility, and we are using public funds, so we should do our best to get the best designs. Ease and speed of design and construction should rarely be considered as basic parameters in a bridge project. So because the period of design and construction is very limited if you compare it with the service life of the bridge. So this is rated with this low profile narcissistic bridges we saw before. It's worth investing in design. And good design doesn't mean expensive design. Or doesn't mean you will have expensive bridge. Or how competition is organized is determinant for the process. So the role of the client is basic. Well, beauty is the result of what is right. This is a Japanese aphorism. It's a sentence I like. Well, the idea of bridge should be all these things: functional, structurally coordinated, aesthetic, durable, sustainable, respectful with history, culture, society, design. Appropriate to many things. The ideal bridge should be all these things, and it's possible. I honestly think that wisely investing in design is possible to have a bridge that fulfills all these points, and from a reasonable, or investing a reasonable budget on it. And well, again, a method is essential and is useful, but not enough. You have a good team responsible for the design and commissioning of the work, and an appropriate allocation of economic and time resources. That's my presentation. Thank you very much for your attention.